Every single day, it rises in the east, warms our planet, and powers pretty much all life as we know it. The sun is just there. It's the most familiar thing in our sky, this constant life-giving presence. But our star has a kind of dual personality, and today we're going to explore both sides of it, the light and the shadow. So that's what we're digging into. We're going to look at the two faces of the sun. First, how it makes our world work, from the biggest planetary systems right down to what's happening inside our own bodies. And then we're going to turn to its violent side and ask a pretty crucial question. Are we at all prepared for the day our star decides to turn against us? So first things first, let's just take a moment to appreciate the sun for what it is, the absolute engine of our planet. Seriously, without its constant stream of energy, Earth would just be a frozen, lifeless rock floating in space. But what is it exactly that we're getting from it? Well, what we call sunlight is so much more than just what we can see. It's an entire spectrum of energy. You've got the visible light, of course, that brightens our world, but there's also infrared radiation, which is what you feel as warmth on your skin. And then there's the invisible ultraviolet, or UV radiation, the stuff that gives you a tan, or a really nasty sunburn. And all that energy gets here incredibly fast. I mean, think about it. The light that's warming your face right now actually left the sun just over 8 minutes ago. It's traveled 150 million kilometers to get here. That connection is happening every single second of every single day. It's kind of amazing. So what does this energy actually do when it gets to Earth? Well, pretty much everything. It's the fuel for photosynthesis, which is the process that creates the food we eat and the oxygen we breathe. It warms our entire planet, keeping the temperature just right for life. It drives the water cycle by evaporating water from oceans and lakes. And it's the power behind the huge weather systems that shape our world. It is no exaggeration to say the sun is the ultimate source of, well, everything that happens on our planet. Okay, so now let's zoom in. Let's go from the planetary scale to something deeply personal, because the sun's influence doesn't just stop with plants and weather. Oh no, it reaches right inside our own bodies and our own brains. Have you ever wondered why you start feeling alert during the day and sleepy at night? Yeah, you can thank your circadian rhythm for that. It's basically a 24-hour master clock inside your brain, and it gets synchronized by one main thing: light. For all of human history, the rising and setting of the sun has been the key that winds this biological clock every single day. But our modern world has thrown a real wrench in the works: artificial light. See, natural sunlight is perfect. It syncs up our internal clock, it tells our brain when it's time to release the sleep hormone melatonin. But artificial light, especially that blue light from our phones and screens late at night, it totally messes things up. It confuses the brain, it slams the brakes on melatonin production, and it just misaligns our ancient internal clock, which, as you can imagine, leads to all sorts of sleep problems. Okay, so we've established the sun as this incredible life giver, but given its immense power, it's totally natural to ask about its role in one of the biggest challenges we're facing today: climate change. Now, we know for a fact the sun's energy output isn't perfectly constant. Over these huge timescales, we're talking millions of years, its little wobbles and variations have been a major driver of Earth's climate, even kicking off ice ages. So the big question is, can that same variability explain the really sharp, really rapid warming we've seen in just the last 60 years or so? To figure this out, scientists use these incredibly complex computer models. And here's what they found. When they run the simulations with only the natural stuff, volcanic eruptions, and most importantly, the sun's slight energy changes, the models just can't reproduce the warming we've actually measured since about 1960. They completely miss the mark. Something's missing from the equation. And it turns out that missing piece is us. It's only when the scientists add the effects of human-emitted heat-trapping gases into those models that the simulation suddenly clicks. The temperature rise in the model lines up almost perfectly with the real-world warming we've observed. And to put a number on it, the warming effect from all those heat-trapping gases is now 56 times greater than the effect from the sun's own natural fluctuations. So while the sun is absolutely the foundation of our climate, the evidence really points to human activity as the main driver of its recent rapid changes. And now, we're going to pivot, because we've talked about the sun as this steady, reliable provider. But there is another side to our star, a violent, chaotic, and frankly, potentially devastating side. This quote here from space weather researchers just says it all, doesn't it? While it looks all peaceful from 150 million kilometers away, The sun is actually a churning, magnetically turbulent ball of plasma, and we live right in its immediate and sometimes very aggressive neighborhood.
The sun's main weapon is something called a coronal mass ejection, or a CME. And this is not just some little solar flare. I want you to imagine taking something with the weight of Mount Everest, turning it into superheated gas, and then firing it into space at 100 times the speed of a bullet. That is a CME. It's an explosion on a scale that is almost impossible to imagine.
And this right here, this is the cosmic battle that's happening all the time. On one side, you have the threat, a massive cloud of solar plasma hurtling towards us. And on the other, our defense, Earth's magnetic field, our magnetosphere. This invisible shield protects us, deflecting the sun's constant stream of particles. But a direct hit from a really powerful CME can just overwhelm it, triggering what scientists call a geomagnetic storm. And this isn't just some theory, it's happened before. Back in 1859, a colossal CME slammed into Earth in what's now called the Carrington event. The impact was so intense that the northern lights were seen as far south as Cuba and Colombia. But it wasn't just a pretty light show, it was a technological nightmare. The storm created massive electrical currents that surged through telegraph lines, basically frying the system across the globe. Wires sparked, operators got electrocuted, and some telegraph machines started working all on their own, powered directly by the energy from the sky. It was a terrifying wake-up call from the very dawn of our technological age. So the Carrington event happened in a world of telegraphs and steam engines. It makes you wonder, what would an event of that same magnitude mean for our deeply interconnected, technology-addicted civilization today? Well, our modern world is this delicate web of interconnected systems, and a severe geomagnetic storm could unravel the whole thing. These destructive currents could surge through our power grids, causing continent-wide blackouts. Our GPS and communication satellites could be knocked out, disrupting air travel, finance, global logistics, everything. Even long pipelines could be damaged. The scary truth is, the technological backbone of our society is way more fragile than we think. And the potential cost? It's just staggering. One estimate puts the economic damage from a modern Carrington-level event at up to $2.6 trillion. And that's just in the United States alone. And the recovery? It wouldn't take months. It could take years. We'd be facing a global crisis where every nation would basically have to fend for itself. And that really brings us full circle, back to the sun's two faces. It is the giver of all life, the engine of our world, the clock that sets our internal rhythms. We literally owe our existence to it. But it is also a volatile, incredibly powerful star that could, in the span of just a single day, send our civilization reeling back a century. So that leaves us with one final question to think about. Are we truly prepared for its power?